An industrial aperture imposes immediate physical constraints on the human body. Before regulations are applied, we must identify the physical baseline of the space itself. Under OSHA standards, a confined space is defined by 3 specific parameters. First, it must be large enough for an employee to enter fully and perform assigned work. Second, it is not designed for continuous human occupancy. And third, it possesses a limited or restricted means of entry or exit. Physical confinement alone does not trigger full regulatory control under OSHA Standard 29 CFR 1910.146. A space only requires strict oversight when those spatial limitations intersect with lethal environmental hazards. That intersection creates the core regulatory tension, differentiating a standard confined space from a permit-required confined space based on recognized hazard potential. A space meets the permit threshold if it contains a hazardous atmosphere or a material with the potential to engulf an entrant. It also applies if a trapping internal configuration, like converging walls or a sloping floor, could mechanically trap or asphyxiate a worker. The final criterion acts as a regulatory catch-all, the presence of any other recognized serious safety or health hazard, such as exposed live wires or unguarded machinery components. Classifying a permit-required confined space is a structured hazard evaluation. It requires employers to address the specific physical mechanisms of asphyxiation and entrapment before a worker ever breaches the plane of the space. To manage these classifications, the OSHA standard provides a decision flowchart to determine the required level of administrative control. At the first operational node, employers must identify if the workplace contains permit spaces. If it does, the employer is mandated to explicitly inform exposed employees of the space's location and hazards, typically by posting danger signs. Moving down the node, we evaluate if the space will be entered, introducing a critical branching logic, the alternate procedure exemption versus a full written program. Qualifying for the alternate procedure is difficult. Employers must prove with objective monitoring data that the single isolated hazard is an actual or potential hazardous atmosphere, and that it can be controlled entirely by continuous forced air ventilation. Alternate procedures do not remove the requirement for atmospheric verification. Bypassing the full permit process requires continuous forced air and rigorous monitoring to ensure conditions remain safe throughout the entry. Verifying those conditions requires a strict testing hierarchy before any employee crosses into the space. This sequence begins with testing for oxygen content to ensure it falls within safe limits. Once verified, Step 2 tests for combustible gases or vapors, ensuring concentration remains below the lower explosive limit. Finally, Step 3 tests for toxic air contaminants. This exact sequence is codified into law for a specific technical reason. Combustible gas sensors require sufficient ambient oxygen to read accurately. A deficient oxygen level renders the combustible sensor inaccurate. Because of this mechanical dependency, testing out of sequence can be fatal. When a space fails to meet the strict criteria for alternate exemptions, the main flowchart pathway activates. The employer must implement a comprehensive written permit space program. The written program legally separates entry operations into a triad of distinct personnel roles: the authorized entrant, the entry supervisor, and the attendant. The operational mandate for the attendant is absolute. They must remain stationed outside the permit space for the duration of the entry operations. The program also mandates specific physical equipment controls, including testing and monitoring gear, forced air ventilation systems, physical barriers, and non-entry retrieval devices. The written program functions as the final physical and administrative architecture, separating an entrant from an uncontrolled hazardous environment. Operations hinge on the physical entry permit document. It acts as the final verification checkpoint and must be posted at the entrance before any work begins. The permit maps to the pre-entry preparations, recording results of the mandatory atmospheric testing sequence and requiring the tester's signature. The document must explicitly state acceptable entry conditions, log the purpose of entry, and carry the authorizing supervisor signature. This document is a time-bound operational contract. If site conditions drift from the parameters specified on the page, the permit instantly voids. Regulatory complexity scales up during multi-employer operations, where host employees and external contractors overlap inside the same restricted space. In these scenarios, the host employer has a mandate to formally coordinate entry operations. They must debrief all contractors on identified hazards, safety protocols, and their specific previous experience with the space. The protocol for dynamic emergencies leaves no room for hesitation. If hazardous conditions are detected, the permit is canceled and all entrants must immediately evacuate. Employers are required to designate rescue service personnel ahead of time and implement strict procedures prohibiting unauthorized personnel from attempting impromptu rescues. Navigating the 1910.146 matrix requires a legally auditable system designed to preemptively neutralize the physics of entrapment. Survival in these environments depends on the integrity of the procedural architecture.